Hello, and thank you for joining me again today to talk about how IBM solutions can help you optimize your virtualization environment. If you happen to miss the last session about virtualization optimization, you're definitely going to want to check that out after you finish this video. In that video, I describe how IBM solutions can provide visibility, control, and automation to that virtualization environment through integrated patch management, backup and recovery, and monitoring of that environment. In today's demonstration, I'll show another set of complementary capabilities that can help with the provisioning and automation of that virtualization environment. These capabilities will be focused on a solution called SmartCloud Provisioning, but I want to emphasize that this is complementary to everything else that you saw in the previous demonstration. So if I start off with another quick chart, I want to focus on four main capabilities that I'll be describing in the rest of this demonstration. The first is going to be pattern deployment. Deploying a virtual machine is something that many hypervisors can do very easily. What about situations where you need multiple, interrelated virtual machines deployed? What if you need to deploy a composite application? How much administrator interaction is required today to do such things? What if you could deploy those patterns with a click of a button? Or better yet, what if your end users could deploy those applications with a click of a button? Image creation. Do your images follow organizational standards? Is that image creation process repeatable? Could you use a single image for multiple purposes? And I'll talk about why that's important as we go along. Image management. How many images are there in your environment? Do you even know? How close are they to one another? Do you already have an image in your environment that you could use for an upcoming project, or do you need to create a new one? And then finally, health monitoring. Do you know the health of your provisioning environment? Service Health for SmartCloud Provisioning is a solution specifically tailored to monitor our provisioning solution so you can find out exactly what's going on in your environment at all times. One final piece that I'd like to mention is that this solution is highly scalable. That means that as your environment grows, the solution can grow along with it. For this demonstration, I'm running with one of the smallest possible configurations, but the great thing is, everything is functional, and I'll be able to show you exactly how the solution works. To give you a little better idea of what we'll actually be working with, I'm going to pull up one of the administrative interfaces to show you what's deployed. In my cloud infrastructure, I currently have a single compute node and two storage nodes defined. So what that really means is I've got two storage systems that can be used to store my virtual machine images, and the reason that I need at least two is so that they can be redundant. If one fails, all the virtual machines running in my small cloud can actually continue to run even with that failure. With regards to the compute nodes, that's where I'll actually be creating virtual machines in my mini cloud. If I wanted to have a bigger cloud, I'd simply add additional compute nodes or storage nodes to allow that environment to grow as my needs grow. So let's actually get into the demonstration a little bit. I'm going to start by deploying a pattern. If you want to think about this from the end user perspective, what I'm going to do is go in and select a predefined pattern to start that an administrator has already defined for me, and that means that I don't need to know anything about the system, and I'll still be able to deploy a complex set of virtual machines. So I'm going to go in and take a look at one of my virtual system patterns, and I'm going to select the simple Tomcat pattern. If you aren't familiar with Tomcat, it's basically just an application server, and so what we're going to do with this pattern is deploy an application server and some web servers to sit in front of it. If I move over and actually look at the pattern itself, you can see that we're going to deploy two different servers. On one of the servers, we're going to launch a script that will do some additional configuration. Now from the end user perspective, all that's required in order to deploy this is I'm going to go up and I'm going to say I want to deploy this into the cloud. I'll give it a name, and all the other options have already been predefined by the administrator for me, scheduling the parts, so I'll click OK, and this will start that pattern deployment. Now deploying this will only take a couple minutes, so while that's deploying, I'm going to create a new pattern. I'll begin by clicking the plus sign to indicate I want to create a new pattern, sample pattern. And then I'm taken to a screen that says, alright, here's your pattern, and right now we don't have any topology defined for this pattern. So I'll say I want to edit the pattern, and we're taken to the pattern editor, and then you see we have three pieces over on the left side that allow us to create our pattern. Parts are basically images. So these are images that have been defined in our environment for use in our patterns. We could use those with any of the image management tools that I'll be describing later, but for now I'm just going to say, alright, I would like a Perl system, and I need an HTTP server, and I'd like a PostgreSQL server. On each one of these parts, these are the predefined images, but we could go in and configure specific things about them. So for example, I could configure the size, and any one of these parameters I could lock down if I wanted to. I could provide a public key, or perhaps some user data to configure additional users. The other thing I could do would be to increase the number of nodes. In this case, I'm saying I would like 3 HTTP servers, and I can lock that down so that the user can't change that. Moving on to the next piece, I could add scripts. So perhaps I want to update the HTTP port that's defined for my HTTP server. In that script, I could provide parameters, so perhaps I want the port to be 8090 as opposed to 8080, and again, I could lock that down. The final component is something called an add-on. So for example, maybe I want to add an additional user to my SQL server. I could configure the username and password if I wanted to, for example. In this case, I'm going to remove that. I also could say I want to order these differently, so I could control what order the virtual machines are created. So for example, maybe I know the HTTP server needs to be created before the Perl server, so I could define the order. I also could change the order of any scripts that would be running. So when I'm finished, I could click Done Editing, and we see our pattern is then down below, and I could then expose this to my end users if I wanted to allow them to create this. Now this was a very simple pattern. It really didn't have too many interactions between the components, but if I wanted to, I could very easily configure those. Let's go ahead and look at one more piece. Let's look at the virtual images. So if you didn't want to deploy patterns, you could also just deploy these different virtual images. So what I'm looking at here is one of my images called Basic 386, and I want to explain one quick thing. You see this piece down here that says Contain Parts. What this allows you to do is include multiple functional roles for a single virtual machine image. The reason for that is I've actually created a multiple personality image in the Image Construction and Composition tool, which I'll show you here shortly. What this does is reduce the number of master images you can use in your environment, and thus reduces the number of master images that you need to maintain. So now that it's been a few minutes, let's go check and see if our virtual instance was created. Okay, great. So I can see that our demo instance was provisioned, and there's our simple Tomcat. If we go ahead and expand virtual machines, we'll see that our 2 virtual machines were created. And actually, if I'd like to see in Virtual Machine Manager, those 2 virtual machines are there running in my environment. So I'm going to expand one of these virtual machines to see a little bit more information about it. So we can see that this is from the Hadoop virtual machine image. And here's the host name and IP address. So if I actually go to this IP address, and look at that port 8080 that was configured, I can see that Tomcat was indeed installed and is working. I hope I struck your interest with that comment about multiple personalities for images, because to me that just seems kind of interesting. So let's go ahead and explore that in a little more detail. So I've now switched over into our Image Construction and Composition tool component of SmartCloud Provisioning, and what I'd like to show you again is how easy it is to create a new virtual machine image if you need to. So I'm going to start off by looking at some software bundles. These software bundles are define once, use many time type operations that you could use in any number of virtual machine images. For example, if I want to take a look at the installation bundle for Apache, we can see that this is going to be used on a Linux machine, and the product that it contains is going to be Apache HTTP server. From a requirements perspective, we can define a number of requirements that must be met in order to use this piece of software. Currently, we just have this defined that it must be a Linux operating system, but perhaps there might be a software dependency, so maybe Apache HTTP server also requires Perl in your environment. When we move to the Install tab, this is where we can define the real intelligence to the system. Here we can upload packages or installation components and scripts that can be used to install different products. In this example, we simply have supplied the required RPMs. You could also use a central repository and configure a remote connection so that you could install software remotely. If you scroll down, you can see the configuration portion can also be used to accept different variables. In this case, we really don't have anything configured, but for example, maybe you'd want to configure the port or installation directory. Next, I'll go to the Configuration tab, and this tab complements the Installation tab. Here we can set any additional steps that need to be performed on the new master image after the installation completes. For example, this might be something that needs to be done on each virtual machine image as opposed to just the master image. The Firewall tab would enable the administrator deploying the bundle to specify any ports that would need to be opened in the firewall for use by this application. So in our HTTP server, maybe we need to punch through port 80 or port 8080. And then finally the Reset tab. On this tab we could provide any scripts that would be required to clean up the master image before capture. So perhaps there's an identifier file that we want to be regenerated each time the virtual machine is created, and we want to remove that then from the master image. So just as a brief summary, software bundles provide the ability for the experts on particular software to pre-package their programs, the setup and configuration scripts, in a single, shareable, and repeatable manner. After it's been tested, it becomes a known commodity, and you can see up at the top that it says published right here. So that means that this package is now locked. If you need to make any additional changes, you'd need to clone the bundle, then update the copy of it with any required changes, test it, and republish that new package as well. After that bundle's been published, you no longer need to be an expert about the piece of software that's being used. You just need to add it to your image, and automatically all this intelligence that's built into the bundle can be leveraged. So let's go ahead and take a look at what an image looks like in Image Construction and Composition tool. I'll go to Build and Manage Images, and in this case I'm going to take a look at our basic 386 image again. We can see over here that this image has been completed, meaning that it's been published into our cloud environment. If I scroll down to the Products section, we can see that right now there really are no products installed. So what if I wanted to add that Apache HTTP server bundle to this image? I'm going to say I want to extend the image. I'll give it a new name and a new ID. I'll say create. And now we see up at the top that it's out of sync, so that means basically this image right now is not out in our environment. And that's okay, but I want to edit it first before I put it in the environment, and I want to add a software bundle. So I'm going to say Add Bundle, and in this case I want to say the installation bundle for Apache HTTP. I'll click Add, and then I'll click Save, and if I expand the product section now, we'll see that we also have our Apache HTTP server. Now the image still says out of sync, so the next step in this process really would be to synchronize it. Unfortunately, in this environment, for this demonstration, this would take a little bit of time, and I realize that everyone's time is valuable, so I'm not going to go ahead and do that. But basically what this would do would deploy a new copy of that image out into the environment, use the software bundle information to install the HTTP server on that image. Then the next step in that process would be to recapture that image so that we could use it over and over and over again in our environment. So I'm going to click Cancel. Before I leave this component, I do want to talk one more time about those multiple personalities. So if I go up to my other copy of Basic 386, and you see the version tree is slightly different here, 1.010. When I go down into the product section, you see there are several products listed in this area. Multiple personalities allow you to have a single master image with multiple applications in place, but you only actually use the applications that you need when they're required. So you see that this image is actually used for 4 different images. If I want to have just an HTTP server, I'm only going to use the Apache HTTP software bundle. If I'm using this as a Perl server, I'm only going to use Perl. So basically what this does is allows you to reduce the number of master images that you need in your environment. So why is this important? You might think that it's tempting to start creating as many single application master images as possible because it is so easy. Why not just create a master for Apache, another master as a database server, another master as an application server? So the reason for that is all those images then would be based on the same master image. But what if that single base master image had a security issue and you needed to apply a patch? Instead of patching just one image, you now need to patch 4 images. If I could have a single master image that had all these different personalities, I then only need to patch one image. Depending on whether or not you wanted to use the multiple personality capabilities of SmartCloud provisioning, you may be able to reduce the master images, but it's still difficult to get a good idea of what's actually in use in your environment. So what I'd like to do next is talk about how the virtual image library can actually go out and determine what images are really out there in the environment for you. So in the virtual image library, you can see, just like last time, we have different repositories that it can be configured. In this case, I'm looking at my high-scale, low-touch environment that I described earlier. And so in this environment, you see I have multiple images defined. You'll also notice that many of these images are the same ones that we saw in our image construction and composition tool. If we look down at the virtual images, you'll see there are different icons associated with the virtual images. Some have this yellow box associated with them. And what that means is that those images are part of our reference repository. What this reference repository allows us to do is versioning for our master images. So for example, we can see a version tree of how a specific image got to where it is today. Let's start by looking at our basic ref or basic reference image. We can see here that it has Red Hat installed, and if I scroll to the bottom, it's been fully indexed and it's fully compatible after remediation. This means that we could use the same image on multiple hypervisors after we perform this remediation. If I go to the Versions tab, we can see any images that are based on this image and any images that this image was derived from. So for example, we started off with basic, we imported it and it became the basic reference image, and then we have another image called basic compat ref, or the compatibility image. So here I've saved a copy that has all these compatibility checks already completed. If I move to the software tab, we can see all the different software components that are installed on this virtual machine image. Then finally, if I move to the high scale low touch compatibility details tab, we can see all the different checks that are performed against the virtual machines to ensure that this image could be used on multiple hypervisors. So let's take a look at some of the other additional functionality that we can do in the virtual image library. One of the most useful functions, I believe, is the ability to see what images are similar to other virtual machine images. One of the best ways to combat image sprawl is to reduce the number of images that are actually the same. You wouldn't believe how many companies have 10 copies of the exact same virtual machine image because Bob got a copy from Jim, who got a copy from Susie, and all of a sudden the same image is out there multiple times and you really don't have any control of it anymore. So what we can do is programmatically go out and index these different images and find out which ones are related to one another. So I mentioned earlier the compatibility image was actually derived from our other reference image. And you can see from a product perspective, and that's what we're seeing right here, we're showing similar based on the products that are installed, they are 100% similar. So if we want to see what's actually different between two images, we can do a comparison. In this case, I'm going to do it on a file level. So I want to compare it against files, and we can see the files that are only on our compatibility image are these 3 down here, so basically some init scripts. On our basic reference image, there are no files that are only on that image. And then in the last tab, we see the files that are on both images but that are different. So we see there were some changes in fstab, hosts, and rc.local. Another way that we can reduce image sprawl is being able to accurately find out if an image already exists in the environment that'll meet our needs. So in order to do that, I'm going to perform a sample search that shows how we could go about finding an image that would address a particular need. So in this case, you see we have the ability to search on name, search on description. We can search by the guest operating system. So for example, if I only want to display Windows systems, I could click search, and then these are the images that would currently meet those requirements. I could also filter based on software product. I'm provided with a filter where I could type in a specific program to look for, and it's going to go out and find the relevant products. I can select the ones that I want. In this case, I'm looking for Perl. And when I click search, we can see that that image list was reduced from 8 down to 2, so I know that one of these 2 images will meet my need, but the other ones would not. And therefore, I don't need to go out and create a new virtual machine image that includes Perl. I hope this section has illustrated how the Virtual Image Library and Image Construction and Composition tool can really provide a comprehensive image management solution from start to finish. However, all of this doesn't matter if my environment isn't fully operational. As I showed in our previous demonstration, IBM has many capabilities around monitoring the different aspects of your environment. What I'd like to show right now is how we can specifically monitor our provisioning environment and ensure the health of our cloud management system. So what I'd like to do is bring up the Tivoli Enterprise Portal, and what we can see here is this is a specific workspace that's designed to go out and monitor the different components of my SmartCloud provisioning environment. So this is our overview dashboard where we can see all the important events. We can see down here the number of images that are available, we can see how much storage space is available, and most importantly, we can see if there are any events raised in our environment. So perhaps we can detect if a specific service is offline, or perhaps a different virtual machine is running out of memory. Like we can see here, my web node was running out of memory. Again, this was on my laptop, so this actually makes sense and it's probably okay. If I go over to the left side of the navigator, we can see some different information. And this information is going to be broken down by the different components I introduced earlier in the demonstration. For example, our storage components, we can see the different images that are available. This is a dedicated storage device that I could attach to any one of my virtual machine images. We can see the different transfers that are going on, disk read and write information. If I expand that, we can see the different storage nodes that I've got configured. I have 2 storage nodes configured, so I have 2 entries, one for each. You can also see that if I had an ESX server configured in this environment, we could pull in the monitoring information for that as well. This section lists all the different internal services that we want to monitor. These are system processes that we know that are critical to having SmartCloud provisioning up and running. And then finally, we have our compute section. Here we can see these are the different hypervisors that are out running in our environment. You see I've got a single compute node, and then these are the different virtual machines running on that compute node and their status. With that, I hope you can see how this solution can help ensure the availability of your cloud solution by combining SmartCloud monitoring with Service Health for SmartCloud provisioning. In this demonstration, I showed several different image management capabilities that allow you not only to build new images, but combat image sprawl in your environment using the Virtual Image Library. I also introduced our highly scalable architecture that all of these components can run on, as well as our easy to use but difficult to replicate pattern deployment capabilities. Don't settle for just provisioning virtual machine images. Combine these capabilities with the monitoring, backup and recovery, security, and patch management capabilities of the first demonstration, and you can truly see why IBM can help you optimize your virtualization environment. Thank you for your time.